So we're on topic 5, it's page 17, and we're going to look at the rectangular coordinate system. And we're going to do, so here's the rectangular coordinate system, which I will discuss. And then we're going to do exercises. We're going to plot points here, plot points on the rectangular coordinate system. And finally, we're going to identify quadrants where points lie. So let's start off by looking at the rectangular coordinate system. And essentially, this means that we're going to place points according to x and y values in this rectangular coordinate system. And if we take the point, for example, 2, 1, this identifies an x and a y value, where the x is 2 and the y is 1. So we have to first of all identify this as the x-axis along the horizon or the horizontal axis, and then the y-axis is shown here, and a point is drawn as the intersection of a x and a y-axis. So for example, here x is 2, and we've got a line going up and down, and then here we're intersecting this with a y value. So here y is 1 and x is 2. So first of all, we do x is 2, we go over 1, 2, and then because y is positive, we move over 1. See, negative values of y are down here, positive values of y are here. Positive values of x are here, negative values of x are here. So we always put the x first and the y second. So again, this is the point 2, 1, because x is 2, and then we move up 1 for the y-axis, and that gives us the point 2, 1. Now we're always starting from the point 0, 0, and that's called the origin. It means that x is 0 and y is 0. This point right here is x is 0, y is 0. It's called the origin. Now, if I wanted to plot the point -3, 2, this means that x is -3, the first number is always the x, and y is 2. So we move out -1, -2, -3. Now the x is -3, and we move up 1, 2 right here, and here's the point where x equals -3 intersects with y equal to 2. So we've got the point -3, 2. X is -3, y is 2. So here the x is negative and the y is positive. Here the x was positive and the y was positive. Let's take the point -2, -3. So here we take the x first is -2, and then we go down 1, 2, 3 to get the point -3 on y. So this is the intersection of x equals -2 and y equals -3. That's the point when both points are negative. They're going to lie in this quadrant, what we call this quadrant here. But I'll come to that in a second. I'll explain exactly how we get each of those values. Let's take the last point. 2 -3 tells us that x is 2. So I go out 1, 2, and y is -3, -1, -2, -3. So this is the point 2 -3, which means that x equals 2 and y equals 3. Now, in quadrant 1, which is this quadrant right here, Roman numeral 1, both the x and the y are positive. So that's a requirement for a point to lie in quadrant 1. Both the x and the y must be greater than 0. In the case of quadrant 2, the x is less than 0. You can see over here. And y is positive because y is up here and it's positive 1, 2, 3. So if the x is less than 0 and the y is greater than 0, which means, by the way, if I say x is less than 0, I mean it's negative. If I say something is less than 0, it means it's negative. And y is greater than 0. If the x is negative and the y is positive, we're talking about a point in quadrant 2. Here, x is negative and y is positive. If both the x and the y are negative, it's Q3. Here, Q1, both the x and y are positive in Q1. In Q3, both the x and the y are negative. If you look over here, we said that the point -2, -3 is here, which is quadrant 3. Quadrant Roman 3. Finally, if the x is positive and the y is negative, okay, x is positive and the y is negative, then it lies in quadrant 4. Here you see 2 is a number greater than 0 and -3 is a negative number. So just to go over here, we change any point in the rectangular coordinate system is defined by an x and a y value. The x value is obtained by moving along this axis right here. We want a positive number, we're on this side. We want a negative number, we're on this side. And the y value is changed by moving the y-axis vertically, so we move either up or down on this axis. So that's the basic information that we need. Now let's go look at some problems here. So the problem says, topic 5, the point 1, 0, where does it lie? So we're going to look for here. Now when I say 1, 0, I mean x is 1 and y is 0. So here's x1. The y means that I'm not going to move up or down here. If y is 0, I'm not going to move, so it lies along the x-axis. So there's the point 1, 0 right there with the black dot. Okay? I want the point -2, 3. What does that mean? X is -2 and y is +3. So I go -1, -2, and I go up 1, 2, 3. And there's the point -2, 3. What about the point 0, -2? This means that x is 0 and y is -2. So I just here, there's the point at which x equals 0, because here we have 3, 2, 1, 0. X is 0 right there. Now I'm going to choose my y, -1, -2. So there's the point 0, -2. Finally, to get the point 3, -1 means I have to look for the intersection of x equal to 3 and y equal to -1. So here I go. 1, 2, 3. There's my 3 for my x. And because my y is -1, I go down and there it is right there. So changes in y, we move here like this vertically up or down. Changes in x, we move like this. Generally speaking, we always work with the x, do the x value and then the y value. Okay, identify the quadrant that each point lies in. So first of all, we're going to do this. We're going to find the where when x is 1 and y in 2, and y is equal to 2, that's this point right here. This is roughly 1, x is 1, and then y is roughly equal to 2. These points are not drawn to scale. We don't have to be perfect in this. You can see very clearly that this is in quadrant 1. So, and this is what we said, if both the x and y values are greater than 0, in other words, if both the x and y are positive, then the point must be in quadrant 1. Here, both the x and the y values are negative, and we said that that has to be in quadrant 3. So here we go off -1, -2, roughly -3 right there. Then we move down 1, 2. So -3, -2. We can see very clearly it's in quadrant 3. What about the point 0, 1? Well, 0, 1 means that x is 0 and y is 1. Here's x equal to 0. And now we move up and y is equal to 1. So since this lies on an axis, it doesn't lie in either quadrant 1, quadrant 2, quadrant 3, or quadrant 4. When a point lies actually on the axis, it's in none of the quadrants. So we see over here, x is -2 and y is 0. That's this point here. This lies on the x-axis. Here it lies on the x-axis. So this point does not lie within a quadrant. If a point lies on the x or the y-axis, it doesn't lie in any quadrant. And we see no quadrant and no quadrant, because it's on the x-axis in D, and no quadrant because it's on the y-axis in C. Okay, let's take a look at page 18. And page 18, we can see there are 3 problems that we're going to do. We're going to do problems 3, 4, and 7. Problems 3, 4, and 7. So let's start with those problems. Sorry for that. Okay, so here's problem number 3. We're told that the problems 3, 3, 3 minus 1, and -1, 3 are 3 vertices of a square, meaning these are at 3 points on a square. Find the point that is the 4th vertex. In other words, they're going to tell us where 3 points of a square are. Where does that 4th one lie if we know the other 3? What are the 3 we know? 3, 3, right here. So there's 3, 3 right here. In other words, x is equal to 1, 2, 3. These are all proximate, and y is equal to 3. So that's 3, 3. The next one is 3 minus 1, so that's right here. So this lies directly underneath here. The x is 3, but now the y is -1. You see, this is y is -1. So we know this point, we know this point, and we know that the x is 3, so roughly here, so it's the same. Y is 3, and here y is -1. And the next point is -1, 3. So we go out, -1, 3, it's there. So we know the red ones indicate the points that we know, the red dots. Now, what we have to realize is that really if we draw this line across here like this, where the y is equal to -1, that would be one of the coordinates. That would be the y coordinate. So y wouldn't change because we know that y doesn't change here. This would have to be -1 over here. Now over here, if we draw this line down, this is x equal minus 1. So it would land up here. So we make x equal to minus 1, and we make y equal to minus 1. We would come out with the fourth point. So here's the y equals minus 1. Here's the x equals minus 1. And so this point right here would be minus 1 minus 1. That would be the fourth vertex. So the fourth order point would be minus 1 minus 1. Let's just go look at that again. Here we're saying that the point here would lie at the intersection, and we drew this line across here and this line here. Because we've got 3 points that we know. These are 2 points of the square. This is the third, and I got to find this fourth value here. Well, this fourth value has to be in line with the y value here. Here y is minus 1. Here the x is minus 1. This would be this here. So I've drawn this right here. Here's the origin right here, 0, 0. So y minus 1 and x minus 1 would be the coordinates of the fourth point. Now, in this problem, we're told that the point 0, 0 and 1, 2 lie in a straight line. Find another point on the line. Well, there's a lot of answers here. We'll try and make it simple. But if you see, here's the point 0, 0, and here's the point 1, 2. So x is 1, y is 2, and these are not drawn to scale, just roughly. One thing you can see, if you look at the relationship here, the y value is always twice the x value. Always. Certainly it's true for here, and it's true for here. We look at this, 2 times 0 is 0, but it's really this number here. We see x is 1, y is 2. So let's just arbitrarily choose a value for x. Let's say it was x is 2. Well, y has to be twice as much, 4. So that's another point that lies on the graph, on this straight line, rather. If we were to choose minus 1 and multiply it by 2, we'd get minus 2. So there are many other examples. We could, for example, say 3, 6, because y is always double x. So any one of these answers would be satisfactory. And obviously, there's an unlimited number of answers to this problem. Try to keep the answers with low numbers. Find the area of the triangle with the vertices minus 3, 0, 0, 5, and 7, 0. So first of all, we start with our x-axis right here and our y-axis right here. So first of all, and here's the origin 0, 0. So now I put the points in minus 3, 0, which means that x is minus 3 and y is 0. So that's that point right here. That's the point right here. Then I put in the point 7, 0, which means that x is 7 and y is 0. Which is right this point here. And finally, I put the point 0, 5 in, which means that x is 0 and y is plus 5. So x is 0, 1, 2, 3, 4, 5, let's say, roughly speaking. So the reason I've drawn these lines here is because, or these two lines, I should say, the reason I've drawn them is because I'm told it's a triangle. So, first of all, we plot these 3 points that we're given. Minus 3, x is minus 3, y is 0. X is 7, y is 0. Both these points lie on the x-axis. The point 0, 5 lies on the y-axis. Here it is on the y-axis. X is 0, y is 5. So I just move up 1, 2, 3, 4, 5 right there. Now, I want to use this basic formula, area of a triangle, which we previously discussed, which is the base times the height divided by 2, or sometimes we say half base times height. This is the base right here, so I need the distance along right here, and this is 10. Why? Because from minus 3 to 0 is 3 units, and from 0 to 7 is 7 units. The y doesn't change, only the x changes. So the distance between minus 3, 0 and 7, 0 is 10. So I know the distance from this point to this point is 10 units. Now, that gives me my base, my height, which is formed as a right angle right here. Okay, this line is at right angles to this because 1 is the x-axis and this is the y-axis, and we know those form a right angle there, 90-degree angle. So the distance from here to here is 5 because the x doesn't change, only the y changes, and it changes from 5 to 0, so the height must be 5. So now I put base times height divided by 2 equals BH over 2. We said the B is 10. The height is 5. 10 times 5 is 50. 50 over 2 is 25. So that completes topic 5, and we'll continue with decimals as it relates to topic 5 in the next video.